Hello and welcome to Mystery Science. Today we're going to be learning about power. This forms part of our Key Stage 3 Energy in the Home series, and this is going to be lesson 3. So those are students in my college will have one of these Energy in the Home booklets, and we're going to be looking at lesson 3 in here. Don't worry, if you're not at my college and you don't have one of these booklets, you can still follow along and you can do the exercises just with a piece of paper. It's fine. Right, so in this lesson, we're going to have a look at power, what it is, why it is, and we're going to look at power ratings of appliances. What does that mean when your TV says 40 kilowatts? Why? We're going to look at what that means in terms of energy transfer, how quickly energy gets transferred from one form to another. And that's literally what power is. And we're going to have a look finally at the end about kilowatt hours, which is really useful to know about if you are ever going to pay an electricity bill, which is probably all of you. At some point in your lives, you're likely to come across an electricity bill that you will have to pay, and it will tell you that you have used 200 kilowatt hours this month, and you will need to know what that means and why it might be wrong. So you can always question these things. But if you don't know what a kilowatt hour is, it's a bit difficult to question. And no, I don't think I have used 200 kilowatt hours, Mr. Energy Provider. I think I've used 20 penguins this month. So it's useful to know what we're talking about. Right, so we're going to start with a do now, as always. How many calories are there in a kilocalorie? Now, you will know this if you've done the work on energy in food, but you'll also know it if you know anything about maths. You don't need to know about calories to know how many calories there are in a kilocalorie. And the same applies for watts and kilowatts. How many watts are there in a kilowatt? If you can do question 1, you can do question 2. Now, something a little bit more involved is how would you calculate the temperature change during a practical? If you're doing a practical and you've got something that's changing in temperature, how would you measure that? Okay, pause the video, jot those answers down, and then see me back here in a sec. Excellent, well done. So, how many calories are there in a kilocalorie? Kilo means 1,000. So there are 1,000 calories in a kilocalorie. Kilocalories are what we use to measure the calories in food. For example, if you pick up a snack bar and it says per 100 grams there are 200 calories, that's actually talking about kilocalories. There are 200 kilocalories. But in our everyday language, we've changed that to mean calories because we're just plain wrong in that respect. But if there's 1,000 calories in 1 kilocalorie, how many watts are there in 1 kilowatt? Yes, you're right. It's 1,000. Kilo means 1,000. Kilometers, 1,000 meters. Kilograms, 1,000 grams. Kilowatts, 1,000 watts. Simple. How do you calculate the temperature during temperature change during a practical? Well, you measure the temperature first and foremost. You measure the temperature, normally with a thermometer or a temperature probe, at the beginning of the experiment, and then you measure the temperature at the end of the experiment, and you take away the beginning temperature from the final temperature, and you will have your temperature change. Okay, let's talk about power. What is it? It's an amazing thing that we've all heard of, and if you watch certain car TV shows, they'll always talk about how much power this car has. But really, it's the rate at which energy is used. That's a technical definition. What does that mean, Mr. E? Well, what it means is it's the amount of energy that gets used every second. It's how quickly something can transfer energy from one source to another. So if you've got a car with a really high rate of power, what's that's doing is it's transferring the energy from the engine to the speed of the car really quickly. So a really high power means that lots and lots of energy can be transferred very quickly. So power is the rate at which energy is used. It's the amount of energy divided by the time it's taken to use that energy. And we measure power in watts, and that's the energy used, that's in joules per second. Now, because this is a remote lesson, I've missed out on telling one of my favorite physicist dad jokes, where I stand in front of the class and I look at them and I pick on one person and I'll say, you there, what is the unit of power? And they'll go, I don't know, sir. And you'll go, what is the unit of power? See what I'm doing here? And they'll go, I don't know. Why, what? I don't know. What is the unit of power? And then they'll go, what? And you go, yes, that's right. And it's hilarious. I bet a lot of you are quite happy that you're not in my class now, although some of you are, so sorry about that. Okay, so power is the rate of energy transfer. It's the amount of energy transferred from one form to another. So 1 watt is equal to 1 joule per second. So 1 watt, that's power. Watts are the units of power. 1 joule, that's energy. And per second, that's time. Per means divided by, so there's our equation. Power equals energy divided by time. That's really simple. And this is one of those equations which actually is quite easy to learn. It's learning what that actually means is the tricky bit, but it means that it's the rate of transfer of the energy. Okay? So you start off with an amount of energy transferred from, let's say, electrical energy to light energy. And if you look at, I don't know, 20 seconds of a light bulb being turned on, you can work out how much power is being used by that light bulb. So our equation then is power in watts is equal to energy in joules divided by time in. Okay, so all of the appliances in your home will have a power rating on them. Your TV, your kettle, your microwave, essentially anything with a plug will have a power rating on it. And what that power rating means is it tells you how much energy is going to be transferred to that device every second. Look at these hair straighteners right here. These hair straighteners use have a power rating of 40 watts. This means that 40 joules of energy is going to be transferred to the hair straighteners every second. So if you leave that on for 5 seconds, then you're using 40 times 5, which is 200 joules of energy. The more powerful your appliance, the faster it transfers energy. So if you have a TV that is 200 watts and then a TV next to it which is 400 watts, the 400 watts TV is the more powerful one, and it's actually transferring energy much faster. Now, sometimes that's not actually what you want. If you have something that has too high of a power, then it's going to be draining power from somewhere. So you're going to end up with a really high electricity bill. So what you're looking for in appliances is something that's powerful enough to do the job, but not a high power rating that's going to sap energy from the electrical system and rack up a massive, great big huge electricity bill. So you really need a balance in between those two things. Yeah. All right, so here's an example question for you. Those of you following along with the booklet, you'll find space at the bottom of the first page for you to fill in this answer. We're going to use the SRAO method. The SRAO method, for those of you who haven't heard of it, is a way of making sure you get marks in tests and exams. Because if you get some of these steps right but get the wrong answer, you'll still end up getting marks in an exam or a test. Whereas if you just write the answer and it's wrong, you get nothing. So it's always useful to do the SRAO method. So SRAO, E stands for equation, S substitute, R rearrange, A answer, and U units. And if you always think of SRAO, you will always make sure you don't miss silly things like the units. Lots of students will just write a number down and forget the unit, and they'll lose a mark. So the first thing we write down is the equation. So let's have a look at what the question's asking us for. A kettle transfers 500 joules of energy in 25 seconds. Calculate the power rating of the kettle. Well, I know an equation that relates power, energy, and time, and that's this one. Power equals energy divided by time. Fantastic. S, substitute. So now I'm going to take the numbers that I know and I'm going to put them into the equation. I don't know what power is because that's what I'm trying to work out. I know what energy is. It's 500 joules. It tells me in the question. And time is 25 seconds. So I just put those numbers in the equation. Power equals 500 divided by 25. Do I need to rearrange this? No, I don't, because my unknown, the thing I'm trying to find out, is the subject of the equation. So I don't need it. What I train my students to do normally is to write out the equation again with the substituted numbers, just to make sure. The answer then is 500 divided by 25, which gives you 20, and we're being asked to calculate power. So what are the units? What's the unit? Yes, they are, Mr. E. Okay, I think I'm done now. All right then, here are some other calculations for you. So have a go at these, pause the video, use the space in the booklet to answer these questions. Don't forget to SRAO. All right, welcome back. So a microwave transfers 30 joules in 2 seconds. Now we're going to SRAO these. So E, equation, power equals energy divided by time. Substitute, power is 30 divided by 2. Do I need to rearrange? No, I don't. So 30 divided by 2 gives me 15 watts. My blender transfers 800,000 joules in 30 seconds. I need energy divided by time. Energy is 800,000 divided by 30, which actually gives me 1.6 megawatts. So megawatts is a million watts, because if I divide 800,000 by 30, I get 1,600,000 watts. So I can write that as 1.6 megawatts. If I spend 7 minutes straightening my hair, which, you know, that's the minimum amount of time that I spend straightening my hair, my straighteners will transfer 252,000 joules of energy. What is their power? So my equation, power equals energy divided by time. My energy is 252,000 joules, but I've got a bit of a problem now because my time is in minutes. I have to use time in seconds. So to calculate the time in seconds, I just use the fact that there are 60 seconds in a minute. So 7 times 60 is 420. So 252,000 joules divided by 420 seconds gives me 600 watts. You must always, always, always make sure the units you're using are correct. You cannot do 252,000 divided by 7. It must be in seconds. Okay, so here are the extension questions. They ask you to do these on a separate page. And I've got a couple of extension questions here. And then on my next slide, I've got some extra extensions for you. So, my toaster was on for 2 minutes. Don't forget, 2 minutes, 60 seconds. It has a power rating of 103 watts. How much energy was transferred? So let's use SRAM. My equation, power equals energy divided by time. Substitute in. Power equals 103 divided by 120 seconds. No, that's not correct at all. Sorry, my power is 103 watts, and that's equal to an energy which I don't know, divided by 120 seconds. So how much energy is transferred? Do I need to rearrange? Yes, because now I don't have the subject as the unknown. So to get energy on its own, I have to multiply both sides by time. So now I have energy equals 103 times 120, and that gives me 12,360 joules. So the last one, my tumble dryer has a power of 500 watts and was used for 45 minutes. What was the energy transferred? The first thing we have to do is convert our time from minutes to seconds. So 45 minutes multiplied by 60 is, oops, the calculator suddenly decided it didn't want to work, 2,700 seconds. So my tumble dryer has a power of 500 watts, used for 2,700 seconds. What was the energy transferred? So we write out our SRAM. Our equation is power equals energy over time. We substitute in the numbers. Power is 500 watts, equal to energy divided by 2,700. Of course, we need to rearrange now to get energy on its own. So we multiply both sides by the time, 2,700 seconds. So now I've got 500 watts multiplied by 2,700 seconds will give me the energy used. And that is, again, 1.35 megajoules. That's 1.35 million joules. Okay, so here is your next extension. Now, this might look really hard to start with, but really it isn't. And I'm going to kind of break convention, and I'm going to give the example of the oven. So if you look, we are this list of equipment. We've got the kettle, heater, lights, TV, computer, oven, fridge, hairdryer, and power shower. So about halfway down, you have the oven. So the oven has a power of 3 kilowatts. So that's 3,000 watts. So 3,000 joules of energy every second being transferred to the oven. And it says here that the time switched on is 1 hour. So to find out the energy used in kilowatt hours, we simply multiply the power by that time. So the oven is 3 kilowatts, which was on for 1 hour. So 3 times 1 is simply 3. So the oven used 3 kilowatt hours of energy. Now, why have we switched from joules, a nice sensible unit, to kilowatt hours, some sort of weird unit invented by a drunken lobster? Well, the reason for this is, as I said before, this is what electricity companies like to use to calculate your bills. So it's quite important to know what the power rating of all of your appliances are, and so therefore you can give the consequences for running them for a number of hours. So the heater, for example, second one down, its power in kilowatts is 2. So that's 2,000 watts, 2,000 joules every second. But it's been switched on for 5 hours. So how much power is how much energy is the heater using in kilowatt hours? So you take the power in kilowatts and multiply it by the time in hours. So 2 times 5, that's 10 kilowatt hours. That's power times time. I'm just going to point out something I've noticed, but I can't change because I'm in the middle of recording. But where it says calculate the energy used at the top, it says in kilowatts per hour, kilowatt/hour. That should actually say kilowatt hour, so that shouldn't have the divided by there, because we're multiplying the power, kilowatts, by the time in hours. So it's just kWh. Okay, so having given you the example of the oven and the heater, I would like you now to just have a go at working out the others. And I'm going to leave you with that and not give you the answers. Ha 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 ha! I'm so mean. But have a go at those. If you have any trouble, then feel free to get in touch. But my students, I'll be checking out the work that you've done anyway. So until next time, stay safe and we'll see you soon.